Welcome back, Algebra 2 students, to section C, checkpoint. Let's go ahead and look at number 1. It says, write a possibly equation for a polynomial with the following properties. It has an odd degree. As the inputs get larger and larger in the positive direction, the outputs get larger in the negative direction, and all zeros are positive. So first of all, it needs to be an odd degree. It needs to be a degree 1, degree 2, degree 1, degree 3, 5, etc., right? So degree 1, x to the power 1, looks something like this. It's a straight diagonal line. X to the power of 3 is a little squiggle, right? And the line goes forever and ever, right? X to the power of 5 is also a squiggle that looks the same, right? Remember we did that? You should have the drawings in your notebook, the ones that we glued in there. So it has to be an odd degree. Now, here's where we're going to draw our sketch. It says that all zeros are positive. So all the intersections, so I have 1, 2, 3 intersections. So I need to have 3 intersections on the positive side. I can choose any numbers on the positive side. So let's say this is a 2, let's say this is a 5, and let's say this is a 7. Okay. It says as the inputs get larger in the positive direction, so as I'm going this way, so as I'm increasing, so as I'm going this way from left to right, the y values are going to get larger in the negative direction. So my y values are going to drop down. That means that I'm not working with a regular odd degree. I'm working with a negative degree. In this case, let's say I'm doing a negative x to the third. That's going to look something like this. Right? As I'm going in the positive direction, as I go in the positive direction, my graph goes down in the y. So that means my graph is going to look something like this. Something like that, okay? So I have all the conditions met. Now let's write my polynomial. So I can say x minus 2 times x minus 5 times x minus 7. But now, that's a positive function. If I want to make it a negative, I just add a negative sign in front. And this is my answer. That's it for part number 1. Let's look at number 2. Sketch a graph of the function defined by f of x equals x times x plus 3, x minus 4, and x minus 4 is to the power of 2. So let's plot our zeros. So if you think back to section B checkpoint, we know that the 0 is going to be the opposite of this plus 3. So it's a plus 3 right there. It's going to be right here at negative 3. That x minus 4 is going to be the opposite. So it's going to be at a positive 4. That x is by itself. Don't forget about that x. That x is just at 0. This is a what degree function. So what degree do we need, or what degree do we have? Well, how many x's do I have? I have 1, 2, 3. Oh, but this counts as a 2. So that means I'm counting this one twice. So that's a 4. This is a degree 4 polynomial. A degree 4 polynomial, but before I answer that question, is it positive or negative? Is there a negative in front of any of the x's? No, there's not, right? So it's going to be a positive polynomial. So a degree 4 is going to look like a parabola. So that means this graph is going to look like a parabola at the end. So I'm going to have this intersection here, this intersection here. I can choose however I want to connect the center. I don't care. I can make it like a W. That's fine. I'm okay with that. And that is it for my sketch. Okay. Let's look at number 3. Number 3 says, consider the functions h of x equals x squared minus 3 of x minus 10, and g of x is equal to x plus 2. So we're going to actually type these two into Desmos. And it says find all values that make this true. So that means I got to type them into Desmos and find where they cross. So let's type this into Desmos. I have Desmos opened up already for you. Luckily, I have the first equation in my first bar, my second equation typed into my second bar. Now I gotta zoom out just a little bit. Okay, I zoomed out just a little bit. And now I gotta see where the red graph crosses my blue graph. It crosses here at -2 and at 6,8. So I'm gonna go ahead and say, I'm gonna remember these values. And I'm gonna say, we're just focusing on the X values, right? So I'm gonna say the X values that make this true are X is equal to -2 and what was the other one? And +6 and 6. Okay, period. This is my solution here. Okay, so hopefully that was easy for us to understand. If you have any questions, feel free to pause the video, rewind and watch it over again, or if not, raise your hand and I'll be more than willing to help you out understand what you just saw. I will see you in the next video. Good luck.